And we're off. So I'm going to share my screen, and we're going to start off with the most basic bit of naming organic compounds. Now, let's start off by saying what we mean by an organic compound. Organic chemistry is not something to do with food and whether it's been grown using pesticides and fertilizer or not. It is carbon chemistry. Organic chemistry is the chemistry of carbon-based compounds. So at the most basic, we have alkanes. Alkanes are carbons that have got every single bond is a single bond, and they are surrounded entirely by hydrogen. So you need to be able to name them based on the number of carbons that they have. 1 carbon, methane. 2 carbons, ethane. 3, propane. And 4, butane. That suffix, meth, eth, prop, and but, applies to all of the other organic chemistry that we're going to look at as well. So on your piece of paper, because I suggested that it would be really helpful to you, and make this so that I can see, no, I need to be able to see my screen above all others, otherwise I can't see what I'm writing. Okay, so let's go. You've got your piece of paper, and I'm going to go over here. You've got your piece of paper. You've written naming organic compounds in the top, and we are going to start off by just putting in the suffix here. Okay, so I've got that. I don't know if suffix has got 2 F's or not. I'm going to go for 2 F's. So we've got the suffix. Okay, and we've got 1 carbon equals meth. 2 carbons equal F, okay, 3 carbons equal prop, and 4 carbons equal but, not but, okay, but, not but. Let's just make that a little bit. I'm just showing you how I'm going to use this so that I can go away and learn all of this. There's no point, let me have a look at how that looks. That's not too bad. Let's make that a little bit better. 1 carbon, 2 carbons, 3 carbons, 4 carbons, like that. Let me have a look at that. Yeah, I can see that. Okay. Now, it isn't really that I want you to be able to read that. I'm suggesting that you have a piece of paper and that you are now putting these things down on that piece of paper as we go past. Okay. The whole point is, I know that you can't see this perfectly. I'm telling you what I just wrote up there. I'm suggesting that you have a piece of paper, okay, to hand where you are doing this now as I go through. So you've got a piece of paper in the middle of it, you've written naming organic compounds. And over in one corner at the top on the left there, you are writing suffix. 1 carbon equals meth, 2 carbons equal eth, 3 equals prop, 4 equals but, etc. Okay, so that's the first thing that I think you should have written down. As I get to things I think you should have written down, I'm going to go and write them as well. And I'm not suggesting that they are easy to read off the board behind me. It's more of where we're laying it out, and you have time to write it yourself. So you've got alkanes written down. You might have also written down the general formula for alkanes, if you can remember it. It is CN H2N plus 2. Let me just put that on a different camera over here. So perhaps I can make it a little bit clearer by using this camera over here. Let's stop sharing a minute so I can see what I'm writing. So remember, when we're doing, where am I? That's my top line there. Okay, so we do C N H 2N plus 2. Okay, that's our general formula for alkanes. How that would work, so for example, methane, that's 1 carbon. So we double it, it's 2, we add 2, means it's got 4 hydrogens. We just put the numbers into the formula and that comes out the other side like that. If we had 2 carbons, well, that means we've got to double 2, which gives us 4, add 2 gives us 6. So I can tell without having to draw it out that ethane is C2H6. Okay, so that's called a general formula. That's called a formula because that's specific. And if we were to draw it out, and I'm going to show you the drawn out ones again now, just so that we've got going. Come along. That's called a displayed formula. That is called a displayed formula, where I've got the C and the lines showing the bonds. So that's alkanes. They're the easiest ones. Okay, they're the easiest ones. I hope by now that you can actually all name alkanes anyway. Methane, ethane, propane, and butane. There we go. We've even got pentane and so on. Hexane, septane, octane. But we only really need to know up to bute. Okay. Then we've got alkenes. Now they're a little bit different. Okay. They've got the same beginning. We can't have methane because you can't have a double bond if you've only got one carbon. Not possible. So we start at ethene. And we've got ethene is C2H4. They have a different general formula. That's just CnH2n. You just double the number of however many carbons you've got. 2, you double it for the number of hydrogens. 2 carbons, 4 hydrogens. 3 carbons, 6 hydrogens. It's a nice, easy one to remember. But this is the next thing that I'm going to go and write on the board. This is the first functional group that we are learning about. The functional group of an organic compound is what is the thing that makes it one of those. Let me explain what I mean. It is an alkene because it has got a double bond between 2 carbons. That is the functional group of an alkene. It has got a double bond between 2 carbons. So I could go back to my board over here, and I know you can't see it very well, but I've done my suffixes up over here. So down here, let's use a different color. So down here, I'm going to write alkenes, okay? Now, the point of this isn't that you're copying it, but that you're making one yourself as you go through. So we've got alkenes, like that. Okay, here we go, alkene. And we've got C, N, H, 2N. Okay, so there's our general formula. We could put alkanes up there. I know you can't read this, but we could write alkenes. We could write CnH2n plus 2. Let's look, is that readable? Not really, it's rubbish. Okay, and then we write functional C double bond C. Okay, so we're looking for that. If we've got C double bond C, okay, and it follows that formula, we've got an alkene. So now I've got some information on this board. Okay, let's have a look at the top. Let me make that a little bit clearer. So I could put alkanes up the top there. Okay, alkanes, and I could CnH2n plus 2. Okay, now I know that you can't see exactly what it says on the board, but I've got naming organic compounds. I've got suffixes. 1 carbon equals meth, 2 carbons equals F, 3 equals prop, 4 equals bute. I've got alkanes, Cn2n plus 2. Alkenes, CnH2n, and the functional group is the double bond, the carbon double bond. So I'm starting to make myself a picture, a mind map that has got naming organic compounds on it. And the ones I've named so far are alkanes and alkenes. They're the nice, easy ones. Now, myself and Mr. Timmins thought it would be helpful if you knew some of the other functional groups before we come back, which we're going to be doing soon, because then we can talk about the chemistry of organic compounds. Now, I mentioned some of them last lesson, last webinar, whatever you want to call it, and said we'll do them again. But what we realized is that actually we can just learn the naming of these things. So the first thing that you have to go away and learn is you have to be able to name alkanes. If I was to say to you, draw propane, you need to be able to draw the displayed formula of propane. So you would need to know that that means it has 3 carbons and it's an alkane. So my formula is double it and add 2. So I've got 3 carbons and I've got 8 hydrogens. And I would have to be able to draw let's go back. Can I go back? You would have to be able to draw propane there like that, C3H8. Alternatively, I might give you a formula like C4H10, and I might say, tell me what that's called. And you would need to know it's called bute something because it's got 4 carbons. And I'm going to see whether it's an alkane or an alkene by looking to see which formula it fits into. So your first 2 flashcards this week are going to be naming alkanes and naming alkenes. And as in particular, using the general formula to do that. Okay, you've got 2 sets of slides here that will help you be able to draw them out at the double bond in propene for now. There is a time when it does, and if you do A-level chemistry, we're going to worry about that later. But for now, just put it at either end. That's fine. Okay. Now, to test for an alkene, you might remember last time, because it's got a double bond, we can add it to bromine water. And if the bromine water goes clear, we know that we've got an alkene. Now, let's look at our third group. So far on the board behind me, I have alkanes and alkenes. Now I'm adding alcohols. The functional group in an alcohol is OH there. Okay. In an organic compound, finding an OH group at the end makes it an alcohol. So if I look at what I've got on the screen, this is C with 3 H's and OH attached to it. Let me just switch to my other camera so I can show you quite what I mean by that, because they're really close to each other. So if I just slide this up, so that's my next line. Fantastic. Let me just make this a little bit bigger so that I can see what I am drawing here. So what we've got here is carbon, and it had 3 hydrogens. So it's a carbon, CH3OH, and it was drawn, C, like that, and it had an OH on it. Now already I'm hoping that some of you can tell me what that is, because it's got 1 carbon, and we've got a rule, meth, eth, prop, bute. So it's got 1. So we know it starts with meth. And anything that's got an alcohol group in it ends in anol. So fantastic. It's got some there. It's methanol. Okay. Methanol. Okay. Absolutely fantastic. So our next one, the one that is in beer or wine. Okay. We've got C2H5OH. Now we know because it's got 2 carbons that it begins with F, and then it's got an alcohol group, so it's ethanol. So that's how we would name alcohols. Let me just go back to my screen then. And I'll change my camera so that we can actually see what I'm talking about. So hopefully now we've got 3 things that we could begin to name. Okay, we've also got a general formula there. It's a bit confusing looking at it like that. I might write it differently on the board in a minute. Don't worry about its general formula, but it is, because that's incorrect, in fact. So I'm going to get rid of it in a second. But what's important is being able to name the simple ones, recognizing that the functional group makes them an alcohol. The OH makes them an alcohol, added on to some carbons, and we've got meth, eth, prop, bute, and so on. We've got butanol, propanol. Propanol is something that people know quite a lot about at the moment. It's really commonly used in sterilizing things, and isopropyl or propanol is often used in spray bottles with spray alcohol in to keep things clean. What's really important about them is that they're brilliant fuels and they're really good solvents. Okay, having the alcohol group makes them all behave in a similar way. Things with an alcohol group all behave in a similar way. That doesn't mean you can drink methanol. It's quite likely to kill you. Ethanol is the one that is mildly toxic and produces the intoxication effect of people drinking alcohol. So the things that you need to know about them. Well, I don't really want you to go away and learn this for this week's task. It's really about naming things, this week's task. But just so you know, you do actually have to know how to make ethanol, the two different ways. There is the fermentation route, which is the making beer and wine. And we can actually get the alcohol out of that through distillation, but also we use ethene, which is produced from cracking. You'll remember from fractional distillation, and we can add steam to it under really high temperatures and pressures to make alcohol really quickly. It's very fast, and it gives us absolutely pure alcohol if that's needed for something. Okay. So let me just go back to my other screen for a minute. Well, not my other screen, my board. We've already got is we've got up here, we've got alkanes. Over here, we've got alkenes. So let's put up here, let's decide to put alcohols. Okay, so you see the name, the alcohols, and not alcohol. They'll be alcohols. Remember, so we're talking about chemistry here, and it is the OH group that is making these. That's their functional group. It's the OH group, and we're putting those up there like that. The displayed formula, I'm going to write the displayed formula on my other piece of paper this time. So I'm just going to switch back over here. Let's have a look what I've got over here. Let's see if I can move that up a bit. And then let's look at the displayed formula for those of you that want to write it down. It's quite easy if we do it underneath. So we've got C, N, and then we've got H, N plus 1, sorry, 2N plus 1 OH. So CnH2n plus 1 OH is the functional group of an alcohol. Now, you don't have to memorize that functional group, but knowing it allows you to work out if something is an alcohol or not really quickly and easy. Okay. Okay, so let me just swap. I'm going to swap going backwards and forwards between cameras. I think you're getting the idea with what I've put on the board now. That's why I've asked you to have a piece of paper and to start trying to put all these things together. You're not going to be able to do the task at the end if you don't have some idea of some of those things. So let me just recap what is on the board behind me. So I have got in the middle, it says naming organic compounds. Then I have the suffixes meth, eth, prop, and bute down one side. Above that, I've got alkanes. They're the easy ones where we just add ane to the end of those things. Down the bottom, I've got alkenes, and that's the one with a double bond inside it. That's the functional group. And then up the top, I've got alcohols that have got an OH on the end of them. Okay. So far, that's what we've learned. There are a few reactions of alcohols that I'm going to talk about now really quickly, but naming them is more important. This is an extension. Can you learn some of the reactions before we come back? Now, a nice easy one is ethanol with sodium. It's not as vigorous as sodium and water. So remember, if you put sodium in water, it fizzes and it catches fire. It's not quite as vigorous, but the main thing to realize is that you get sodium ethanol oxide, and you get hydrogen given off. Okay, so you get plenty of hydrogen. You don't need to know the formula of this. You just need to know that that's what you get, and hydrogen given off. That's the bit that's important. And if you burn ethanol, it burns very cleanly. Okay, ethanol, by cleanly, it just produces water and carbon dioxide. You get nothing else. It's a very nice, clean burning fuel. Okay, it doesn't produce smoke or soot of any type. Let's move on. Right, oxidation of alcohol. Now, oxidation of alcohol, we can use all sorts of different ways. So we can add an oxidizing agent, we could burning it, but the one that you're going to get asked about all of the time is vinegar. If you leave alcohol, if you leave a bottle of wine open and you just leave it for days on end, it will start to taste of vinegar. And the reason for that is that vinegar is an aqueous solution of ethanoic acid, and ethanol exposed to air in the presence of microbes becomes oxidized and turns from ethanol into ethanoic acid. So vinegar, for those of you who are doing French, it means sour wine. And it is literally, we often produce it chemically now, but often if you buy cider, apple cider vinegar and red wine vinegar, it is just oxidized alcohol that has turned into ethanoic acid, which is the base of vinegar. So vinegar is an aqueous solution of ethanoic acid. We're going to get to the acids in a minute. So what do I think we've covered so far already today? I think, I think in naming these compounds, we have named alkanes: methane, ethane, propane, butane. How do we know they're alkanes? They have no double bonds. We've then named alkenes. We know they're an alkene because they contain one double bond. And we have a general formula for them: CnH2n. The number of hydrogens is double the number of carbons. We can't have methane because you can't have a double bond with one carbon. So we have ethene, propene, butene, pentene, if we really want. The fact that they've all got a double bond means they will behave in a similar way. Remember, we can do polymerization with those, addition polymerization. Then, if I move my head a little bit, we mentioned alcohols. They all have an OH group on the end of them. Because they have the same functional group, they all behave in a similar way. They make very good fuels, they burn well, and they are volatile. They evaporate easily. They make good solvents. The two key reactions where they combust well in oxygen, giving you just carbon dioxide and water. And they also react with sodium to produce sodium ethanoate, and also hydrogen given off, important. If you leave alcohol open in the presence of microbes, it will oxidize into ethanoic acid, which is a solution of which is vinegar. Okay. So far, I think we've got those things. And what I'm asking you to do, myself and Mr. Timmins are asking you to do this week, is to be able to name and draw these things. Now, this is our next group. So the groups we've learned, oh dear, it says my internet connection is unstable. That's worrying because I've got another little while to go. Now, what I've got here is a carboxylic acid, Ethanoic acid, vinegar, is an example of a carboxylic acid. And I'm going to show you some of the different ways that they are named. That is methanoic acid. It's got one carbon. The one that makes vinegar is ethanoic acid. It's got two carbons, and so on. We can have hexanoic acid. We can have propanoic acid. They just follow the same rules, but they have this bit on the end. They have a double bond to an O, and then a single bond to an O and an H. I'm just going to switch over to my other camera. Aha, I'm going to stop sharing. So sometimes these confuse people because what we've got here is what you saw there. We've got the carbon. Okay, so we've got H, and we've got H, and we've got H, and we've got a double bond going over there, and we don't have that there. A double bond going over there, and we've got an O and an H down there. Okay, but how you often sit, so that is the carboxylic acid group. So the carbon double bond O on like that. That's the carboxylic acid group, but often you will see that written as COOH, like that, just written like that, because us scientists are lazy and we just write it out to that. So we've got carbon, two oxygens and an H. That is the carboxylic acid functional group. So were I to be using my other camera now, so was I back over here? Okay, so somewhere on your piece of paper, you are going to now need to add carboxylic acid. So get yourself, again, I know that you can't read this. This is carboxylic, So it's YLIC, carboxylic acid. And we've got C, double bond O, single bond O, single bond H, or COOH, like that. Okay, so we've got our carboxylic acids. Good. Carboxylic acid, C double bond O, sometimes written like that as well, COOH. Fantastic. And the one of those, so hopefully you've now got a piece of paper that looks a little bit like that. Obviously, I'm aware this is blurry. This is just about layout. Right, now, that's a good question about the HOOC. I'm going to, in a while, I'm going to get onto something called diacids. And yes, we can write it backwards as well if it's at the other end. So that one comes at the end if we're going left to right. But if you've got one at each end, the one I'll show you. I'll show you rather than say it because it gets too confusing. But that was a good question. Let's just get onto it. So on your thing of things to learn, so you've got suffixes, meth, eth, prop, bute. You've got alkane, completely saturated, general formula. Alkene, not saturated, double bond, general formula. Alcohol, contains an OH group. Name a few, draw a few. Draw methanol, ethanol, propanol. Make sure that you can draw those. Carboxylic acid, methanoic acid, ethanoic acid, propanoic acid. Draw them out. They're not too difficult. That's methanoic acid. Oh, look, here we go. Methanoic, ethanoic, propanoic, butanoic acid. 1, 2, 3, 4, but it's still got the same group on the end with the functional group COOH. Methanoic, ethanoic, propanoic, butanoic. Make sure that you can draw them. Make sure that you can recognize the formula. And we've got some reactions down there. Again, that's a bit of challenge for you. That's not the standard piece of work that myself and Mr. Timmins are expecting. What we're expecting is that when we come back to school, you have revised this and we can say, right, draw propanoic acid, and that you would be able to draw this one here. Or one of us draws this on the board and say, because you have learnt the suffixes, meth, eth, prop, and bute, and you know that if it just had an OH on it, you'd be saying that was butanol, but it's not. It's got the C double bond OH, and so you know it's in oic acid, and so you're calling it butanoic acid. That's what we want you to be able to do. If you can also remember some of these reactions that we've put at the bottom of the things, that's wonderful, but that's going to a next level. Okay, naming them is the most important thing that we want you to be able to do. Let's just move on from that. Okay, now this, however, is important. All carboxylic acids are weak acids. They generally have a pH of about 3. Okay, acids have to dissolve before they become acidic. So you have to put, to make vinegar, which is an acid, you have to put ethanoic acid in water. You have to have a solution of ethanoic acid in water. And it becomes about pH 3. And the reason is because they don't lose their hydrogen ions as easily as things like HCl, hydrochloric acid. It loses all of its H's, and all of its Cl's separate. You've got tons of hydrogen ions. That makes it a really strong acid, lots of H pluses. Carboxylic acids, they don't ionize completely. Some of them come apart and then they join again, and then some other ones come apart. They don't lose their hydrogens quite as easily in solution. And that means that they're not as acidic. Okay, they don't ionize properly. This we will go over again in school. We're expecting you to learn the names: meth, eth, prop, bute, alkane, alkene, alcohol, carboxylic acid. There's only one more, don't worry, I'm nearly there. Okay, so I want you to be able to draw these and name them. I'll show you the task in a minute. Okay, here are some reactions of carboxylic acids. Again, I said this is extension. Some of you are going to find it easy to name these. Okay, that's brilliant. If you do find it easy to name them, you find you get to the end of the webinar and you could do it already, go back and start learning some reactions. If you find it hard, it's absolutely fine to just be learning how to name them and draw them. That's okay as well. Okay, now we're on to esters. Now, these aren't esters yet. We make esters by adding I can speak some days, I'm going too quickly. That's because I keep watching the time. We add a carboxylic acid to an alcohol. Okay, so here we have methanol. Now, I got asked, can you write them backwards? Yes, you can. This is OH because we start at the middle and we go out. So this is OH. It's not HO. We start at the middle and we go out. So we've got an OH group over here because we've drawn it on this side instead of that side. We've done that on purpose because we're going to add these two things together. And we've got ethanoic acid. We know it's ethanoic because it's 1, 2 carbons. That means it's Eth, and it's got a COOH on the end of it, which means it's a carboxylic acid. So that's how I named it. And when we join them together, okay, when we join them together, what happens is the OH and the H there form water, and then this O attaches to this line here. So hang on, there we go. So that's gone. And now what I should really have drawn is a long line in between these two. They move closer. So you just have this off the end of that. I'll draw that on the board in a minute. How we name it is like this. We start with the alcohol and we change that into methyl. So it was methanol, so we have methyl, and then we just get the next bit and we go ethan and we end it in O8. So methyl ethanoate. That ester is called methyl ethanoate, and we always make water as well. Okay. If we added ethanol together, that would make ethyl ethanoate, because we get the alcohol and we change it to eth. We change it, we take the suffix and we add YL, and then we take the acid and we change it from ethanoic acid into O8. Okay, so we have ethyl ethanoate. So if I go back, whoops, okay, so methyl ethanoate, because it's the alcohol comes first, methyl ethanoate. The next one, ethyl ethanoate, is that ester when we join those two together. And now it shows them nicely joined together. So what happens is the H from the alcohol joins to the OH from the carboxylic acid, and it makes water, and the whole thing joins together. We use the alcohol's name first. This was probably just change the end of the name, and that's it. But the alcohol comes first. Esters are brilliant. Now, I talked about polymers last week, and we looked at polyesters, where we join lots and lots and lots of these together using diols and dialcohols. Now, a dialcohol simply means it's got the OH group on both sides. That's a dialcohol. And a diacid has just got the acid group on both sides. Dialcohol and diacid. Double alcohol, double acid, di. You can make a polyester out of those because you can make a big chain. But ordinary esters, monomer esters, are brilliant. They're amongst my favorite chemicals because they smell incredible. They have really, really distinctive smells. They normally smell of fruit. They have really strong fruity smells. Often people say they smell like pear drops. They're really commonly used in fruit flavored sweets and also in perfumes to bring fruity smells. Okay, they have, I mean, really strong fruity smells. And those of you who were there when we were learning about plant hormones, ethylene, which is a type of ester, is the really strong smell of bananas that you get. So that is an ester, and that's that really strong banana-y smell. They're very volatile. They evaporate easily. That also makes them really good solvents for things like perfumes, because what you want is the scent to be left and the solvent to go. So they are really, really useful compounds. They're the hardest, I think, to get around the idea of naming. So what you need to do is you need to draw a few of these out. You need to draw a carboxylic acid. Draw yourself ethanoic acid, methanoic acid, propanoic acid. Pick an alcohol, methanol, ethanol, propanol, butanol. Add them together and see if you can come up with a name. So if you started with butanol, you then have to have butyl. So you take the first part of the name, BUT, and you add YL to the name. Okay, so it's butyl something, and let's say you used ethanoic acid, it's butyl ethanoate. Okay, so you're always going to end it in YL for the alcohol, and you're going to change that carboxylic acid into O8, OATE. You're going to need to draw some of these out. What is the functional group of an ester? So how we do this is they like to draw it out as the C. So it is the C double bond O in between two other carbons. It's the link in the middle. And how that often gets drawn is they've drawn it as COO, but I just want to go and show you something else because I think that there's something missing there. So I've got my other camera. I'm going to stop sharing. I'm just going to, in fact, I'm going to put it under the carboxylic acid. So underneath the carboxylic acid, so we had a carbon joined to a carbon with a double bond O like that, going down to another O, going off that way to another carbon. So that's what we had. And it gets written as COO, but I think what's important is it's normally got a line on either side of it like that, okay? Because it's joined to something else. It's got something on either side of it. Now, back to my other camera. I'm perhaps trying to do too many different things at once today, but we'll see. So what I think we've done so far, here we go. So where do I think we're at? I think we've done alkanes and alkenes. Okay, really, that's nice and simple. And then we did alcohols, functional group OH, ending anol, methanol, ethanol, butanol, propanol, hexanol. Carboxylic acid ends in anoic acid, ethanoic acid, methanoic acid, propanoic acid. That's the functional group there. Now, ester has got a C double bond O in the middle of it somewhere, and it's ill anoate. So whatever the alcohol was ending in YL, and whatever the carboxylic acid was ending in anoate, ethyl ethanoate. Now, you might notice that some of these formulae look a little bit odd, okay? And so this idea, a displayed formula, remember, is when you draw it out. So when you're drawing out the carbons and the hydrogens, that's called a displayed formula. This is something else you need to learn. You need to learn functional groups. You need to be able to name them. You also need to be able to have an idea of a structural formula. A structural formula is, I'm not expecting you to learn how to write them, but to recognize them. So what scientists, chemists often do is, you see you've got C2H5 here. Well, you've still got C2 and you've still got H5. But what that chemist is trying to do is show you how to draw it. So I'm going to show you what I mean by that by, yet again, swapping cameras and stopping sharing. I hope I have time to do this. So here are the different ways. So they have written, let's have a look on my pen, right? C2H5OH, right? That is ethanol. But that kind chemist decided to give you a structural formula. So they said CH3, whoops, CH2OH. Well, why is that structural? Because what that means is I have a CH3 joined to a CH2 joined to an OH. It is breaking it down into the different pieces. So you draw that, then you join it to one of those, then you join it to one of those. It's showing you the structure, the shape of your molecule, okay? And I would like you to be able to recognize them and draw them, but not necessarily be able to come up with them entirely on your own, okay, at this stage. Okay. But if you're trying to work out how to name something, you can just count the carbons and the hydrogens in it. So OH, but you can see it's got 2 carbons, so we know it's ethanoic acid because it's got 2 carbons in it, like that. Okay. Now, let's just move on. There are some tests here. Again, this is a bit of challenge work. So what I really want you to be able to do, do I want to talk about diacids and dialcohols? Not really, but just show you something. So alcohol group, OH, and I was asked if you can write them backwards. If there's one on either side, you do write them backwards. So ethanol means it's an ethanoic, it's ethanol, but with an alcohol group on both ends. OH, OH there. Hexane dioic acid is hexane, 1, 2, 3, 4, 5, 6, but it's got a carboxylic acid group on both ends. And notice that we write it backwards if it's on the left-hand side, because we start at the middle and we go out like that. So that's, if you're feeling flash, you can look at dialcohols and diacids as well. So let's just get rid of that. I was going to talk about some of these, but let's not. Okay, so forget these ones. I'm going to delete them from the slides, maybe not. How long have I got? There's the task. So what I want you to do, functional groups that we've looked at: alkanes, alkenes, alcohols, carboxylic acids, and esters. That's a definite. Absolutely need to do those. If you're feeling flash, dialcohols and diacids as well. Let's leave amines out of it for now. Make flashcards for each functional group, be able to draw them, name them, draw the displayed formula, recognize the structural formula, and name them. Practice drawing them out. It'd be really helpful if you drew out some of those and just uploaded a photo so that I can see that you know what you're doing. That way I can look at the photo, so can Mr. Timmins, and we can just spot any glaring errors that you're making. Okay, because what we want you to do, this is prep as well as work for at home, because we are going to be seeing if you can do this when you get back in. More advanced, those of you who find that easy, add in the amine group that I just had at the end there. So add in amine, NH2, that's an amine. Don't worry about polyamides, just add in the amine group at the end there. And also see if you can learn some reactions. So you should be able to predict what can be made if you look at some of those things. Now, I did have a little bit of a Kahoot. I don't know how much time we are going to have, but I'm going to try. It's not got many questions in it, this Kahoot. So if I stop sharing and then I find my Kahoot and then I start sharing again, we should all be good. Right. If you've got questions about this, email me. We might have some time at the end, but let's just see how this Kahoot goes. So what I have done here is what have I done? What have I done? Oh dear. I've broken it. Stop share. I can fix it. I don't know if we've got time, but I'm going to try. I'm really sorry that this hasn't worked exactly the way that I wanted it to. Depends how quickly my email goes now. This doesn't have many questions in it. It's just to see if you can spot them. So what this Kahoot has got in it is here it is. I've got it. So it's all fine. It's got pictures made out of mods. So those, I'm sorry if it's been glitchy for people. I see that copy now in the thing. I have recorded it, so I will put it up. So what I've done is make them out of mods. And see if you can now. If you've been making one of those as we go, this should be quite easy for you. It's not going to work. Nope, it's decided it doesn't want to work, so we won't be playing that. I will post it as a, let's just try one last time, teach. Nope, doesn't work. So I will post it as an assignment as well, and you can go through and see if you can work those out to help you test yourself. So today's tasks, there is the making those flashcards or mind map, however you do it, to learn them. You need to ideally put some photographic evidence of that just so that we can check you're getting it right. There's a quiz. Once you've made your revision resources, use them to answer the quiz. If you can answer the quiz, your resources are good enough. If you can't answer the quiz, you need to go back and make some more resources. And then there's the Kahoot as well. If you can use your resources to work out the answers on the Kahoot, then you've got it. If you've revised them and you think you know them, and you're, we come back to school in a week's time and you can absolutely tell me them in our first lesson, well, do the Kahoot, see if you can answer it, because if you can, you're going to be able to get all of the questions I ask you right. Brilliant. I'm going to stay here and answer any questions. Otherwise, thank you very much for coming. You are welcome to leave. You are welcome to type a question in the question box. Nope, see everyone leaving. So I'm going to end the webinar in that case. Thank you all very much.